Yo 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 and welcome back. Last video I felt that the pace of development got a little stale and the pace of exciting things got a little slow. So I actually spent quite a few hours just before this exposing all kinds of things to Zig from C++, so we won't have to do that on this video. Rather we can try to actually get something new and interesting on the screen. And I hope it will work out. This is completely untested. I haven't even actually run the game since I set this up, so let's have a look. Let's have a look and see what happens if I just run the game now. Hopefully I have everything. Nope, not that. I have everything built. Well, things seem to at least run, so that's good. So, in this video, let's try to actually get this screen showing up when you hold down a button or something along those lines. And we will do that with a UI canvas. So basically the thing we started looking at last time, we exposed, what was it? Was it the label? I think it was the label from Goofy. And we played around with this a little bit. Exposed the set position, get position, that kind of stuff. And I don't remember if we actually spoke about the canvas. I think I mentioned it. But now we have this canvas thingy here. And the idea of this is that the canvas is also a widget, but it doesn't really do anything by itself. Rather, it gives you the ability to render essentially anything that you want from code. So it gives you like, well, it gives you a canvas. It gives you like a small area of the screen, and you can create that just like you can create any widget. But then you call this new set render callback function, which I hope will work correctly now, because as I said, I've never actually tried this, never actually even called this method. So let's see if it works. And we will do that by going into the HUD view script. So we have this test label, right? What actually happened with this? I think I reverted some code. Does that thing even show up? It does. It says, hello, subscribe, please. And that is perhaps a little bit silly, but never mind. Let's actually, we can probably actually remove, well, essentially everything from here. Let's just do that. Just move everything, and instead we will create a new canvas, and we'll call this, what do we call this? We call it avatar role selection screen or something like that. All right. And the position 0.5, 0.5, that would place it in the middle of the screen. Let's not do that. The size 0.01 will make it like 100th of the screen. Let's not do that either. Let's start with something like 1/10 of the screen. Center, UI pivot center, yeah. Let's move it like down to the right, and put it at like 15, so that would make it 85, and that now it should appear in the lower left corner, and it should be there essentially all the time. So yes, we don't really specify how it will look in here. We just tell it, okay, you have a name, you have a position, and you have a size. And I don't actually even remember if it supports anything besides those. Let's have a quick look. This we need to do on the C++ side, unfortunately. Right, so we can give it a name, we can give it a Z order. So we can like, render it above or below something else. A size, position, and we can bind the visibility and position to properties. These are really handy things, and we will at least use this later on to bind the visibility to the property, so it's not visible all the time, only when you hold down this one button that we talked about. Okay, so that should be good. We'll save that, and now if we run the game, nothing will show up, but what we can now do is, or well, nothing new will show up because we haven't hooked up this render callback. So now I'm quite nervous actually here because I have no idea if this will work and if things will just completely break. But let's do this anyway. So what did we call it? Avatar role selection screen. And this is a goofy UI canvas pointer. It's probably actually an optional pointer. No, it's actually, yeah, well, it doesn't need to be a pointer there because this whole type is sort of like a pointer. It says it right there in the name, so we just make it null, like that. And I think that might be everything we need right now. So what we can do now here then is when we init this thing, we get the HUD view there. So let's put a line there to signify that this is kind of development things. We're kind of testing these things out still. So we have G HUD view, and we call we're not C++ anymore. Get widget, and what we want is, of course, the canvas pointer. And we give it the name, and the name is come on. The name is this avatar role selection screen. Yeah, that is the name. Okay, and now if we have this guy, G avatar role selection screen, we need to capture it. So if screen, something along those lines, so save, it will add an unused or a discard here for us. So what we need to do here is we need to hook up the render callback. So we can do set render callback, and this takes a render callback, and it doesn't want to go there. That's annoying, but yeah, we can see that it is a void delegate 4, and this 4 just signifies that it has 4 parameters. So you can only see the types here. You can see the first type is a render context. The second is the actual pointer to the canvas. And then you have 2 vector 2s. And the first one is the pixel position, and the second is the pixel size. Maybe we should actually write that here, because it's essentially the same as what we have on the C++ side. If we go to like this one, for example, you can see here's the equivalent on the C++ side. So this is pixel position, and this is pixel size. So what is pixel position and pixel size? Well, Goofy tries to be resolution independent, at least in most cases. And so when you're specifying a position here, for example, in the script, you're giving it in normalized coordinates. So all the axes go from 0 to 1, and you don't really talk about pixels here. But when you render something, you actually need to render it according to some resolution, and we're talking about actual pixels here. And so you get the position of the canvas here in pixels, and you also get the size in pixels. So that is what that is. Yeah, I don't think we necessarily need to comment on those two. They're kind of obvious. But anyway, that is what we want. Let's move that up to the side. And then let's just put a function here. Function, should we maybe just think about this a little bit. Like, is this the place where this thingy is gonna live? It might be. But to be able to draw this thing, we need to know quite a bit about, like, what is the current avatar, who is controlling what vehicle, so that we can show the correct entries there in the menu, because this will essentially be a menu of all the different roles that the player can take. But maybe I'm getting a little bit ahead of myself. Let's just make sure that we can actually draw this. So I'm just going to put it here right next to this. I'll probably revert this particular code anyway. So render avatar role selection screen, and the first thing we want the second is canvas. It's also goofy. UI canvas pointer. And then we have pixel size, pixel pos. So position, that's of basis math vec 2. And then we have pixel size, which is of the same type. And it is a void. And why does it not actually create this on a new line? I don't know. That's weird. I think it should do like you should do this basically when I have a comma after the last one. It doesn't currently for some reason. Well, let's see what happens. Maybe because of these ignores. Zig is a little weird sometimes with these things still, like the tools are still evolving quite a lot, so anyway, what we can do now is I think I mentioned briefly previously that the goofy rendering is handled with a third-party library. So we can just go here and we can go to NanoVG. So this is the library that I'm using to render. It's a very nice little C library for rendering. Mostly like vector graphics, but it also supports rendering just textures, raster graphics. But this allows me to have a sort of resolution independent effects and shapes and all of that. And as part of the stuff that I mentioned previously, that I've exposed quite a lot of things just before this video, I exposed quite a lot of this functionality to Zig. So here we have all kinds of things. This is not the entire NanoVG API, but it's a fair bit of it. I think we should be able to probably do quite a lot with this. I am gonna cheat a little bit and see how I did it previously. So you have something like objective marker. This might not actually be like the very best. What should we do? We should do something like mission info, perhaps. Yeah, this is probably quite all right. Yeah, we have like a rounded rectangle, and here you can see like this NVG begin path for example, NVG begin path is part of the nano VG. So we will do goofy.nvg.begin path, and then you can begin path in the very same way that you do here. I have exposed it as part of Goofy because I do use some of my own types here. Like NVG has, for example, its own color format or color structs, and I use basis colors here in this. I mean, I could essentially, at least in theory, I could have just used this directly from Zig because it's a C library, and Zig communicates with C quite well. But I decided to wrap this as part of Goofy, so that's why it looks a little different. But most things are essentially exactly the same. Anyway, let's start by testing this out and seeing if we can get like a box on the screen, essentially. So NVG and begin path is what we want, and we want to pass in the context to it, and then we want to do NVG fill, and again we want to pass in the context to it. And in between these two we can now draw things. So we can do something like Goofy NVG colors. We can do fill color, and we do context, and then we can do basis color orange, for example, and that should be it. And then we need some kind of geometry to actually draw here. And as I said earlier, we are talking about pixels here, and not really the normalized coordinates that we're typically talking about. And I had some helper functions here on the render context. This guy doesn't really have anything yet. Like it calculates like some aspect ratio and something like that. But I had a very handy function here on the C++ side, which I will copy paste in here, and it will be unhappy with me for a while until I have commented this out. But given a UI size, you essentially you calculate a pixel size from that UI size. And this is perhaps not the absolute best way to do that, but basically what I do is I just get the width of the rectangle, and I multiply that by the UI size, and so that gives us something to work with. So let's just add this here as well. So we can do pub fn, and then this will be self const self, and then UI size f32, and it will also return an f32, and we will get so we get essentially x, that essentially does it for it, doesn't it? Yeah, x size, self max x, self min x, max x minus min x. Yeah, that's exactly what we want. So we just return essentially that. So do that, and then that returns an f32, right? Does it not? Oh, we need self there. That's an f32, and we just multiply it by UI size. All right, so that gives us something to sort of to work with. And yes, so now we can do something like we can do like if we have a rounded rectangle, we can do corner radius, and we can do context get pixel size from UI size, and we just give it some UI size, something really, really small. So 1 would be like, it would be the width of the entire entire canvas, right? Yeah, I think it's the width of the entire canvas. So we want something really small, something like, what do we make it? Like this would be 10%. Maybe 10% is okay. Let's go with 10% and see what that looks like. And then we can do goofy. Oop. Goofy. And NVG. And rounded rectangle. Context. And we give it the pixel pos. Pixel pos.x. It doesn't like me when I do that, then I start using it. Right? Pixel pos.y. Well, it doesn't seem to really like me at all now for some reason. Why not? Why don't you like me? Size is width, or width is size.x. Height is size.y, because we essentially want to fill the entire canvas with this background here, and then we give the corner radius here as the last parameter. So that's that. I think that should allow us now to have that rendered for us. And so now we need to actually hook this up, right? And we can do that by doing render callback dot nope. Is it goofy? Canvas render callback, yes. Dot init, and we can init one of these delegates either as just a straight up function or as a method. And here it is a function because this is not like a part of a struct or anything. So we just do init and we give it like this. Okay, I think this should work. So set render callback, and we give it the callback like that. Let's see if this actually builds, and it doesn't. So const is yes indeed, and we need to mark that as mutable. And I don't know what this is. Hello. Go and click it and it goes away. Okay, so that succeeded. Wow, I'm really nervous now. Is this gonna just completely blow up? Well, it doesn't blow up, but it also doesn't seem to call it. Okay, so one reason, of course, might be that it never went there, right? I think what we'll do here at this point to just make sure that these things are actually called, because I might have some stupid mistake here. I'm not like kicking off the whole process or something like that. So let's build that in debug, and let's build this in debug, and let's see what happens. Another option is that this is not found for some reason. Might also be. Let's make sure that we are in the correct project first of all. Yes, we're in means, and we're creating a canvas in the HUD view. Looks good so far, and yes, it succeeded. So let's try this. And it goes here, and it seems to be hooking it up correctly, right? And so initializing the delegate, and yeah, everything seems to be working. but for some reason it doesn't look like it's getting rendered. Okay. Then what we can do is we can run the whole thing here from C++ instead and try to debug this part. I mean, we can debug this from Visual Studio Code as well, but I think it's generally easier to do it like this. Let's make sure we have the wrong projects set up here as the startup project. Let's make sure we have the correct parameters, which we don't. So yes, nothing is set up correctly here. Let's set those, and now we can see what's happening. Prototest level. Okay. We can perhaps verify here that the UI, it's actually the data. The data should give us the name if we go deep into this. And you can see avatar role selection screen. That's cool. Right, render callback. Yeah, so that's still false. Interesting. So I don't seem to set that properly. So goofy zig interrupt. Yeah, see, I forgot to set this. So this would be why, and that's actually an int bool. So do it like that. Yeah, int bool is really a workaround for a Zig bug, which may or may not be fixed in recent versions, but I still have this concept of int bools in the interrupt layer. Right, now let's go back. I have a good feeling about this now, so let's go back and let's. Did I build that in release? I think I did. Yeah, built it in release. Right, so let's go back here and again nothing happens. All right. Right, it still doesn't call that. Okay. I probably have some other place that I haven't done. Like I said, you're getting this completely. Yes, here we go. Okay, getting this completely untested, which you can see. All right, so this thing probably gets called. We can try to make sure that actually is the case. If we put a breakpoint here, put a breakpoint there. No, okay. Still doesn't seem to be called, but it might just be our debugger misbehaving now. Let's see. So canvas, right? We should get here, right? Yes, we do. Okay, and here is where we actually call into Zig, and so we do actually get here. Yeah, it's just like when we don't do anything with any of those. So Zig has probably just, we're discarding everything. Zig probably just optimized away this thing, which is good. Okay, so anyway, NanoVG context, C++ pointer, right? These things here are really, most of these actually go into constructing a UI render context. One of these guys. Let's move that to the side. So what we want is, we want to create a pixel rectangle, which is an axis aligned bounding box, or AABB, and we want a 2D. AABB. So let's do const pixel rect. I should get used to actually writing it like this. And that would be basis math AABB 2D and I should probably actually do something about this that I can't actually yeah, let's just do that. Let's create a constructor here which just takes 4 points, right? So min x f32, min y f32, max x f32, max y f32. So now we can do init and we can do min x, min y, and init max x and max y. So that's what we want. And why is this being init empty, right? So init, what do we call this? Init coordinates or something. There's no operator overload. Well, operator overloading, no, but also no function overloading in Zig. So you can't call it really whatever we want. There's no other init function here, so we could call this init. But is this like the most? Is this the most natural prototype for an init function? I don't know. I don't know, but we can leave it like that for now. Right, so init, and now we can do pixel rect min x, pixel rect min y, pixel rect max x, and pixel rect max y. And let's try this. Put a comma there. It really doesn't want to cut this line for me for some reason. Let's keep going. Maybe it does it when we don't ignore all of the things anymore. Or discard, I guess is the right term. Okay. What about vec2? How did we actually... Still like, yeah, there's a from interop in vec2, so we can do that. So we can do const pixel pos would be basis math vec2 from interop. And using the same same name here, so that's not good. That's just we need to make it somehow. We need to make it somehow different from that. Yes. Okay. That's a pointer, so we need to do something like that, right? And then we have the size and size. And what then? Then we have the canvas CPP pointer. We can do canvas is goofy UI canvas pointer, init from CPP pointer, canvas CPP pointer. Like so. Screen width, screen height. Yeah, now we have everything we want. So now we can do the context. So we can do goofy UI render context, init from, actually we should just call this init. It would be init from CPP pointer if it took only a CPP pointer. But this is supposed to be just init. And we will give it the NVG context CPP pointer. We give it the screen width. We give it the screen height. We give it the pixel rect. And we give it, well, nothing more really, right? don't really give it anything else. But that looks somewhat good. Still discarding some of these because we're not using them like any further. Now we have this callback map, and what we need to do here is we need to get a callback out of this guy. So I think we can do if get, and the key is the canvas CPP pointer, and we can capture it. I think we can do all of this in one go. So now we need to do call, and what was the exact? Oh, we're in canvas here. So it's render context, canvas pointer, then pixel pos and pixel size. So render context is that guy. Then we have canvas. Then we have pixel position vec2 and pixel size vec2. And now we should use everything, right? Yes. Now we don't discard anything anymore. Still don't know why it doesn't want to actually cut the line there. It's a little annoying, to be honest, but oh well. All right. So anyway, we're constructing all of these types of the correct type from the interrupt types and all of that, and then we're figuring out. Okay, so the delegate, zig delegate, containing our function pointer to the callback on the zig side, which C++ has no idea about. It was stored previously here in add render callback into this G callback map hash map. It's an auto array hash map, where the key is the C++ pointer of the canvas, and the value is the render callback itself. So we need to figure out, okay, do we actually have one of these guys? And if we do, then we call that. Okay. All right. So now then, hey, would you look at that? This is not a very good rounded rectangle. It's probably just because we have the corner radius set too large. So let's make it smaller. And where is our callback? Why can't I? Here it is. It's right here. Let's make that like 0.01. And of course, like the nasty thing about this, and this is something that I perhaps want to actually change in the future, is that Goofy is pretty nice to use. Yay! See, now it works. Or now it looks like a rectangle rather. And yeah. Right. So what was I saying? Yeah, like the nice thing about Goofy is that you can just make changes to these scripts and it updates on the fly. But that's of course not really the case when you have code like this, and you because the code is not hot updated, at least not yet. I think the SIG guys are working on actually hot reloadable code, which would be very, very nice. But yes, okay. So now we have this thing here, and so if we consider this to be like a menu, like this is a little too small to be a menu. Like if we make it the size, if we make it like this, we can put it in the middle now, just to make our point. Now if I go back, I just saved. The thing is gone. And you might be wondering, why is it gone? Well, there's one more thing I need to actually expose to SIG to make hot reloading with these canvases work, because it's recreating when I save I save this thing, I make some changes here, and I save the thing. It actually creates a new screen and a new HUD view and a new avatar role selection screen. And of course, that new one hasn't gotten this render callback set, so it can't really do any kind of hot reloading currently with this. Oh, okay, now it's where did I put it? Where did I put it? Yeah, so the position I wanted it to be in the middle, and we make it like half the screen. The size, like the width is half the screen, right? So yes, this looks correct. It looks like it's half the screen and it's centered. And I think, like now, if we scale this down, you can see that it like the UI is trying to maintain its original aspect ratio, and that's why it actually it tries to maintain the same shape that it did, regardless of what size the screen is. You can also set it to stretch. I think somewhere here. Where is it? Where is it? Oh, it's actually probably here, right? Init UI, yes, contain, and there's another one called fill. And now if we shut this down, I think now it should stretch it so that it tries to fill the screen rather than maintaining this aspect ratio, which we have hard-codedly set to 16:9 here. Because different games might have different needs for this sort of thing. Oh, I blocked the process. Yeah, so now you can see that it just stretches to the whole screen, and it doesn't actually maintain its shape. Now it becomes really thin, and it looks like a capsule now. So that's why it sort of behaves like it does. But anyway, now if we go here and we go back to the script first of all. So it's a little wide like this. Let's make it maybe a fourth of the screen, or yeah, let's make it a fourth of the screen. Actually, no, that's not. Let's make it 0.2, and let's make the height a fourth of the screen, and we'll put it back there in the lower right corner, roughly. Yeah, so that looks somewhat all right. Let's maybe move it a little bit further to the left. So something like that, then maybe 0.8, something like that. And also, like, the pivot is now in the center of the box, and yeah, that's probably all right for now. And so the next thing then is that we don't want it to be orange. So we can do something like oh, actually we want probably alpha there as well. So we do init RGBA, and we do we just do 0, 0, 0, and then like what do we do, like 50, something like that. And yeah, ideally this sort of thing would be scriptable from this script right here. The reason I haven't really done that is, first of all, AngelScript is kind of not the programming language or scripting language I want to use for this project, because it's so tricky to actually bind it to SIG. Obviously it works now, but that's because it's bound to C++ rather than SIG. So it would be actually kind of problematic to expose anything from SIG and have it like usable from here. Right, so this looks like it could be a menu in the for selecting the roles. Yeah, so that's one thing. The other thing is that I don't have any like IntelliSense or anything like this. I mean, it gives me some hints here, but these are based purely on what it has encountered. Like if you can do like with the name, it suggests it to me. But if I wanted to do the binding, which is something like bind position to property or whatever, then we don't have anything like that. So it's kind of tricky actually to write these scripts without just constantly looking at the C++ code. And so that is one reason why I haven't actually exposed this render callback thing to AngelScript, because I'm kind of figuring out how I want to script these things in a Zig-based project. So yeah, this is a little impractical, to be honest, to do it like this. But yeah, it is what it is. Right. So before we end this episode, I'm gonna try some other things here to make sure that we have this, and we can perhaps like get this turned into a proper menu in the next episode. So if we do const font, and then we can do goofy and nvg, and we can do, and then oh, actually maybe we don't actually need to store it anywhere. I think we can just do goofy nvg.fontface, and the font that I have created and exposed elsewhere is called standard. So that is what we're going to use. And what do we do? We write something here. We write something. So we do goofy.nvg.text. And yeah, the first one is context, and the second one is X, and that's now in pixels. So let's do 10. It will be pixels. Won't actually scale nicely with the thing, but it doesn't matter. Hello, subscribe, because that is what you're supposed to write when you're doing things on YouTube. And right, what do we need else? We need font size, maybe. Goofy nvg font size context. What would the size be? I think it's supposed to be very small actually. So let's start with something really small. There's no F's in Zig. And as for the color, I think is it fill color? I think fill color, I think, is the one that text uses. So the basis color green or something. Just testing it out again. Yeah, that might be enough. Might be everything we need. Okay. What? Oh. Yeah, it returns something. I think it might return like the width of the text or something. I don't remember actually what it does. But I just basically recreated this API like verbatim from the C header. So if it returned a float, I returned a float from this without really thinking about it. Let's see. Okay, it's not doing anything, but that might be just because I'm using this incorrectly. Let's make that a little larger. Let's make it a lot larger. I'm looking here on my other screen to see if there is anything obviously wrong. Oh, yeah, it might actually have been have been visible. So the thing is that we need pixel pos. It might actually have been right in the upper right corner, yeah, because like you can really essentially render anywhere on the screen from this render callback. Like NVG doesn't care if you render outside of the canvas itself. But yes, that's why you get this position and size, so that it helps you if you want to stay inside of the canvas. Yeah, that didn't work. Pixel pause. Do we need to like... I mean, there should be some text align already. Goofy NVG text align. That would be context, and then we can do Goofy NVG align left and top, I guess. We need to use the asint, I think. Is it? Let's go to align. Yeah, asint is the one. And we can just OR this together with another one. So NVG align top and asint. I mean, I would assume that it has some default alignment, which would be left and top, but I don't know. Maybe not. Maybe not actually. Peculiar. Let's see. If we go into right, so we go nano VG. This is now the C++ side. Do we get some sensible stuff out of this? Is optimized the way and not available. That that doesn't sound good. That doesn't sound good at all. Yeah, we do get the string there, so it's just our... it is just our debugger being a little silly. Okay. Maybe we should do the same thing now with this and try to debug it in debug mode. Right, so that was already built. Debug is nice because it builds so very fast. SIG release is not that fast yet, but I think they're making improvements to the build speed for SIG, which should make it a lot faster. Okay. So what do we have? X is 202. That sounds reasonable. And Y is 739. That also sounds reasonable. Yeah, all of this looks good. We have hello subscribe, and we have... am I doing something wrong here with this? No. Like I think I did that correctly, but I might not have. So let's take the end out here and just make this a null pointer for now. That's actually not where we are. We're in there. Just to check if I did something stupid. And yeah, I don't think this is serial terminated now, so that's also sort of a problem probably. Let's just quickly do a string copy, something like that, and that should be length, and then we just pass it the C string. Like, this is not as efficient because we're making a copy of the string there, but that should let us check for a few potential bugs in my wrapping code. Yeah, it's not showing up for some reason. So that's a little annoying. I think I might actually end this episode here and just figure this out. Oh no, let's not do that. I'll figure this out and then I'll continue. So hold on to your seats, and I will be back in like, well, it'll be like 1 second for you. All right, I immediately found it when I turned off the recording. I mean, I swear sometimes like recording the video makes you very stupid. So I just had the font size set to very small. I remember having to use like really small value for some of these things at some point, but apparently not here. But yeah, I put this to 20 and I ran the game and it just worked. So boom. Hey, hello, subscribe. Right. So I think we should be able to just create a reasonably nice menu with this, but I need to sort of think a little bit about how to actually go from, like, first of all, where should we actually render this thing, right? Because now we're rendering it in here in the UI view model, in-game UI view model, which is not necessarily the wrong place to render it. But this thing has very little information currently about what the player is doing, the avatar of it, etc., etc. And the information that we want to render is here in this vehicle avatar component. If you remember from the previous video, we have this list here, role list. And so this guy needs to essentially like report what roles are available, how we can switch between them, etc., etc., and get that into the thing. So yeah, it needs to be sent here somewhere or somehow, and it still might be the correct place for it, but I need to sort of figure out how to actually send it here. I think a message is probably the correct way to do that. But yes, that will be in another episode. But one thing that we could still do here, just as a fun little test, is currently the thing just shows up immediately when you start the game, and that's not good. So we're supposed to be able to hold down like a button, and it will appear based on that. So if you hold down, I think I subconsciously have been thinking about the Q button on the keyboard and one of the like bumpers on the Xbox controller, shoulder buttons maybe they're called more generally. And if you don't have any roles, it will just tell you like no additional roles available, but otherwise it will show you the menu, and when you let go of the button, it will disappear and change the role if you have moved up and down in the menu. So we can just very quickly test that. We need to do it with like proper game input, which we won't go into now, but we can do not that. No, but we can do another thing. We can subscribe to a message category. So message node subscribe to message category, and this will be basis engine messages. This is another one of these places that don't really give you any intelligence, because this is actually coming directly from the C header. But if we look at engine messages, there's a message category called raw input, which we can use. I'm gonna actually quite soon, I think, just duplicate these things in Zig so that we get proper intelligence for them. But yes, raw input, and raw input has a bunch of messages that you can listen to. That's window blah blah blah. Where's the raw input? Here's the raw input. So key pressed, key released. These guys. Actually, am I listening to any of them? I am actually. Cool. So we can copy this guy, and here in on message received, just copy this in. That would be basis.engine messages blah blah blah, and yeah. So we take all of this, and here we get the key code, and the key code is. Yeah, well, you can do, yeah, exactly. You can do this. So you can do key Q, right? So Q, key Q. I can type. Apparently, key Q and in key Q, we want to, when we press it, we want to show the menu, right? And when we release it, which is another message entirely, we want to hide it again. What did I do? I did something stupid, didn't I? That's where we want it. So released, like so. Yeah. So show here, hide here. So how do we do this in a nice way? And the nicest way is probably to do it via a property. So here in init, we can do something like this. We can do goofy. Should be here. Do need to do it earlier actually. Basically, what I'm gonna do now is I'm gonna, yeah, I think I need to do it in the UI manager before I create the HUD view. Here is where we create the HUD view. I'm gonna create a property, and then here we actually have a method for it. So this is the correct place for it. Yes. So just as a test and as a demonstration, we can do register property. All right. The type is a boolean, and the property name. This would be something like HUD. Roll screen visible. The initial value is false. It's not visible, right? And I actually have a whole file here for these kinds of names. So yeah, it would go in here. But let's just try this out and see if it works. Right, so we register the property here. We set the initial value to false. And now we can do in the script, we can do something like this. We can do bind visibility to property and give the name of the property here. So first of all, let's make sure this works. It should now go away because its initial value is set to false. release building is slow. No matching symbol bind visibility to property. Okay, so what was it called then? See, this is the problem I was talking about. Like, it's a little annoying. It's called bind visibility to property. I think that is what I wrote, but maybe not. Visibility. Yeah. Okay. Yeah. So now we don't get any errors, but it also doesn't show. So in in-game UI view model, what we can do now is we can let's just so that I don't typo this. Let's take the name. This is why I have them in a separate file so that I get the auto completion. But we can do goofy manager set property value bool true and false. And I think that should be it, to be honest. So raw input can only be used for keyboard and mouse, and it's sort of like the inputs are hard-coded here in the code, so they can't be rebound or anything like that. There's a whole system for actually setting up proper game input, as it's called, which can be rebound and can be mapped to game pads and things. Now if I press down on Q, we get the thing. Hey. Right, so if we consider this, we're driving around with this, and then we want to switch to the crane, and then we can just hold down Q and like move down with the arrow keys or something inside that menu, and then it would switch to the crane. That would be my plan. Okay, so cool. I think this is enough for now. We had a go at this, and there was some stupidness again involved in this. Me making stupid errors and me having forgotten to implement certain things and all of that. But that is game dev for you. Cool. Next time we will start properly looking at implementing that menu, and maybe we'll finally get a little closer to the actual crane, which will be really fun. So, hope to see you next time.